Imagine a medical field that has completely exploded in popularity over the last few years. Like, we are talking about treatments that promise to restore your confidence, bring back physical comfort, and solve incredibly intimate problems using literal space-age technology.
Right. But at the exact same time, this very field is facing stern, highly restrictive warnings from major regulatory bodies, like the FDA and the UK's National Institute for Health and Care Excellence.
Yeah, it is a fascinating landscape of contradictions. You've got absolute cutting-edge engineering colliding head-on with very real, very serious medical caution.
Exactly.
Yeah.
It's a lot to unpack.
So today, we're cutting through all the glossy cosmetic clinic marketing. We are doing a deep dive into the peer-reviewed clinical studies and strict regulatory guidelines to figure out what actually happens when high-powered lasers meet highly sensitive human anatomy.
Because we are looking specifically at non-surgical vaginal rejuvenation today.
Right. And the core question we want to unpack for you is all about precision. When a clinician uses an energy-based device to treat vaginal laxity, are they just like applying a blunt, one-size-fits-all blast of heat? Or can these machines actually be customized for wildly different anatomical zones?
Which is crucial, right? Because you have the deep internal canal, and then you have the highly sensitive outer entrance, the introitus.
Exactly.
And the distinction between the internal canal and the introitus is, it's arguably the most critical safety question in this entire field.
Yeah, it really is.
But to understand how these devices protect the patient, we first have to look at what they're physically doing to the human body at a cellular level. We have to understand the mechanism of action.
Okay, so we are essentially talking about intentionally applying thermal energy or heat to delicate tissue. In the clinical sources we're looking at, there are basically three main types of technology being used to do this. How are clinicians actually delivering this energy?
Well, the overarching biological goal of all these treatments is a process called neocollagenesis.
Neo meaning new, and collagenesis meaning creating collagen.
You got it. The thermal effect is designed to stimulate the body's own fibroblasts. These are the specific cells responsible for manufacturing the structural framework of our tissues, the collagen and elastin fibers that give tissue its strength and stretch.
Okay.
So when you apply controlled heat or controlled damage to the area, you wake those fibroblasts up. You force them into a repair state, which increases local blood supply, boosts the production of glycogen, and ultimately thickens the tissue.
It sounds a bit like aerating a lawn.
Oh, that's a good way to put it.
Yeah, like when you want a lawn to grow thicker, you use a machine to punch tiny holes in the dirt, right?
Yeah.
Creating purposeful microtrauma. And the grass responds by growing deeper, stronger roots to repair the damage.
That lawn aeration analogy is absolutely perfect for understanding the first category of devices in our research. The ablative CO2 lasers like the FemTouch or NuV.
Okay, because ablative means it's physically vaporizing the tissue, right?
Exactly. But they aren't just burning an entire surface. They use a fractional approach, meaning the laser beam is split into a microscopic grid. Yeah, it creates a matrix of tiny, controlled, microscopic injuries on the mucosal surface, leaving healthy tissue in between those dots. The body detects those tiny injuries and rushes in to repair the area, flooding it with new collagen.
Right, but obviously vaporizing tissue, even on a microscopic level, isn't going to be the right approach for every single patient. Some people might need, like, a gentler method that doesn't break the surface at all.
Which brings us to the second approach in the sources, non-ablative ear-YE lasers.
RYE.
Right. Devices like the Photona Smooth, Incondylase, or Gynolase fall into this category. The fundamental difference here is the wavelength of the light. These lasers do not cut, punch holes, or vaporize the surface.
So no micro-injuries.
Right. Instead, they are tuned to safely deliver deep heat into the mucosal layers without causing thermal necrosis, which is cell death.
Okay, so you get the heat necessary to wake up the fibroblasts, but without the micro-injuries on the surface. And then there is a third category that doesn't use light energy or lasers at all, right?
Yeah, radio frequency or RF devices. So the EM-FEMI 360, Forma-V, and Thermiva are common examples. Instead of light, they use electromagnetic waves to create electrical resistance in the tissue, which generates heat.
Wait, electrical resistance?
Yeah, and what's particularly clever about RF technology is that many of these devices incorporate built-in surface cooling. The wand itself stays cool against the top layer of the tissue, protecting it completely, while the electromagnetic waves heat the deeper subdermal layers to that magic collagen-building temperature.
Okay, so we have micro-injury, deep laser heat, and electromagnetic waves, all essentially tricking the body into rebuilding its own structural integrity. But here is where I get genuinely skeptical.
Okay, let's hear it.
If I am the patient sitting in that chair, my immediate concern is my anatomy. The deep vaginal canal is one thing, but the entrance to the vagina, the introitus, the vestibule, the vulva is a completely different landscape.
Oh, absolutely. It is vastly more innervated. The density of nerve endings at the introitus is incredibly high compared to the upper vaginal canal.
Exactly. So if a doctor has a laser firing deep inside the canal and they slowly pull it out toward the entrance, what stops them from accidentally hitting those highly sensitive external nerve endings with the exact same blast of energy?
Because applying the internal energy to the external tissue sounds like a recipe for absolute agonizing pain.
Yeah, it sounds awful.
It would be excruciating. And this is exactly why the clinical protocols for these devices are so rigidly structured. The manufacturers and the medical guidelines, they totally recognize that treating introital laxity requires a completely different approach than treating canal laxity.
Right.
These are not blunt instruments. The device settings are manipulated on a granular level to respect that anatomical shift.
So let's break down how that manipulation actually works in practice. If a clinician is using one of those ablative CO2 lasers, the ones aerating the lawn, how do they adjust when they reach the sensitive entrance?
Well, let's look at the specific protocol for the FemTouch system, detailed in the clinical literature. When treating the deep endovaginal canal, the standard protocol dictates an energy fluence of 10 millijoules.
Yeah, millijoules, got it.
Right. And the spot density, meaning the percentage of tissue actually being hit by the laser grid, is set between 10 to 15%. The physician fires the laser, rotates the probe 60 degrees, fires again, and works their way down the canal.
Okay, so that's the heavy-duty setting for the deep tissue. What happens at the transition point?
As soon as the probe reaches the introitus and the vulvar zone, the protocol mandates a hard shift. The clinician deliberately dials down the energy fluence to between 7.5 and 10 millijoules.
Oh, so a pretty significant drop.
Yes. But more importantly, the speed and intensity are now dictated entirely by real-time patient feedback. The protocol requires the physician to constantly assess the patient's tolerance level in that specific moment. They do not just blindly drag the internal setting out to the external tissue.
That reliance on real-time feedback is crucial for something that actually breaks the surface of the tissue. But what about the non-ablative lasers, like the ERYEG systems that deliver deep heat without cutting? How do they handle the transition without accidentally burning the patient?
So the non-ablative systems often take an even more structural, hardware-based approach to safety. In the incontinence protocol, for example, the treatment is broken down into distinct steps.
Okay.
Step 1 is the internal canal. The clinician uses a specialized speculum called a G-runner. It fires the laser at a frequency of 2 Hz, delivering an energy density of 10 to 11 joules per square centimeter.
But they can't just use that G-runner on the sensitive vestibule outside.
They don't. When they move to step 3, which targets the introitus and the vestibule, they're required to physically swap out the hardware on the machine.
Wait, really?
Yeah, they remove the internal adapter and attach a completely different piece, known as the green GRAPG adapter.
Oh, wow. So they're physically altering the machine itself to enforce the safety limit. That's fascinating.
Precisely. This new adapter fundamentally changes how the machine operates. It automatically drops the firing frequency down to 1.6 Hz, slowing the delivery of energy.
Okay.
And it strictly caps the energy density at 10 joules per square centimeter. This ensures the clinician physically cannot deliver the same rapid high-intensity heat to the outer tissue that they were using internally.
That's super smart.
And furthermore, the clinical manual specifically instructs the operator to deliver fewer laser pulses when working near the urethral meatus because that specific anatomical structure is acutely sensitive to thermal buildup.
I mean, that is a brilliant way to engineer safety into the process, removing the risk of human error by forcing a literal hardware swap. And I assume the radiofrequency devices follow a similar logic.
Oh, with RF, the separation is even more distinct. If you look at a system like the eFemi 360, the clinician doesn't just swap an adapter. They use entirely different physical wands.
Really? Entirely different wands?
Yes, there's one wand engineered exclusively for the 360-degree environment of the internal canal, and a separate, distinctly shaped external applicator designed solely for the flat, sensitive vulvar tissue.
Okay, so what we are seeing across all these technologies is like dial-level control over the actual physics of the treatment. The clinician controls the peak power, which determines the depth of the thermal effect, They control the pulse length, dictating the heat buildup, and they control the physical spread.
Exactly. The entire system is engineered so that the thermal effect fundamentally respects the varying sensitivities of human anatomy.
And that level of precision engineering is what separates modern clinical treatments from the blunt instruments of the past, which is incredibly reassuring.
It really is.
But, understanding that the technology is highly adaptable and safe is only half the battle. The other half is figuring out if it actually does what it claims to do.
Right, the efficacy.
Yeah, because one of the sources we reviewed points to a headline from the Guardian newspaper which suggested that these vaginal lasering treatments for postmenopausal women might essentially just be a placebo.
Yes, that headline.
Yeah, so if we are claiming that lasers rebuild collagen and physically tighten tissue, how do we prove that objectively?
So that Guardian headline actually highlights a very real historical flaw in how this field used to operate. For a very long time, the primary way clinicians measured the success of a vaginal rejuvenation treatment was by relying on subjective data.
Questionnaires and things.
Exactly. They would give patients standardized questionnaires like the Female Sexual Function Index or the Vaginal Health Index score.
So they're essentially just asking the patient, do you feel better? Is intercourse more comfortable? Do you feel tighter?
Yes. And the problem with subjective questionnaires in this specific area of medicine is that the placebo effect can be incredibly powerful.
Right.
A patient might report feeling better simply because they spent money on a treatment or because they're finally receiving medical attention for an intimate problem, or even just because they're experiencing temporary swelling from the procedure.
Oh, sure. The inflammation makes it feel tighter temporarily.
Exactly. Their satisfaction scores improve, but their actual anatomical structure hasn't changed at all. To prove that neocollagenesis was actually happening, the scientific community needed hard, measurable, objective data.
Which leads us to one of the most fascinating pieces of diagnostic technology in our source stack vaginal tactile imaging, or VTI.
VTI fundamentally changed the game for proving efficacy. It's a biomechanical probe equipped with an array of highly sensitive pressure sensors. When the clinician inserts the probe, it physically measures the tissue's pressure resistance. It essentially maps out exactly how much mechanical pushback or elasticity the vaginal walls possess, and it provides that data in hard numbers.
Hard numbers, like what kind of numbers?
Specifically in kilopascals.
Wait, so instead of asking a patient how they feel, a computer is literally measuring the mechanical grip of the tissue before and after the laser pulses. You completely remove human bias and the placebo doubt from the equation.
Entirely.
So what happens when you put these laser treatments to the VTI test?
The clinical study tracking fractional CO2 lasers using VTI produced some really dramatic results. Before the patients received any treatment, the VTI probe measured the maximal pressure resistance in the anterior vaginal wall, the front wall.
Okay, what was the baseline?
The baseline average was about 23.8 kilopascals.
Okay, 23.8 is our starting point. What happened after the laser treatments? And more importantly, how long after? Because we know temporary swelling can skew results, right?
Yes, and the researchers knew that too. They deliberately waited 10 to 12 months after the treatments to conduct the follow-up VTI measurements. They wanted to ensure they were measuring permanent structural remodeling, not temporary inflammation.
Wow, almost a year later.
Yep. And at that 1-year mark, the pressure resistance in that same anterior wall had nearly doubled, jumping to almost 43 kilopascals.
Wait, 43? So the physical tissue was pushing back twice as hard.
Exactly. And the researchers didn't just stop at biomechanical pressure tests, they also performed histological exams.
Meaning they looked at it under a microscope.
Right, they took actual physical tissue samples from the patients before and after the treatments and looked at them at a cellular level.
So if the pressure sensors show the walls are physically firmer, the microscopes must be showing actual structural changes. Are we seeing literal thicker walls under the lens?
That is exactly what they found. The clinical terminology notes that the stratified squamous epithelium layer was physically thicker.
Hold on, let's translate that for a second. Stratified squamous epithelium, in plain English, we are talking about the outermost protective mucosal layers lining the canal, right?
Correct. The surface lining of the tissue was significantly thicker and healthier. Furthermore, the microscopes showed that the density of the connective tissues in the lamina propria, which is the deep layer just beneath the surface where the collagen lives, was vastly increased.
So the body had genuinely manufactured new structural support.
Yes, the lasers worked exactly as engineered.
Okay, let's zoom out and look at the picture we've painted so far. We have high-tech lasers and radio frequency devices that can be meticulously customized to protect the highly sensitive introitus.
Right.
We have hard biomechanical pressure data and microscopic tissue samples proving that these devices physically rebuild collagen and thicken tissue. I mean, it sounds like an absolute miracle solution for anyone experiencing
It
looseness.
really does sound like magic.
So why are the FDA and the UK's NICE issuing such strict warnings? Like, why are major regulators aggressively pumping the brakes on a technology that clearly works?
It all comes down to the danger of the word laxity and the absolute necessity of an accurate medical diagnosis. The technology is miraculous, but only if it is applied to the correct problem.
Right. Our sources from the Women's Health Clinic and the NICE guidelines really emphasize this. Because a patient might walk into a cosmetic clinic and say, I feel loose, or I'm experiencing vaginal laxity after childbirth.
Exactly.
And a clinic operator with a shiny new laser machine might say, great, you have laxity, let's rebuild your collagen. But that feeling of looseness might not be a tissue problem at all.
And this is where the medical caution comes in. Think about what we just discussed regarding how these devices work. They target the mucosal lining and the immediate subepithelial connective tissue.
Right, the surface and just below the surface.
Yeah, they do absolutely nothing to strengthen the deep pelvic floor musculature.
It is exactly like trying to fix a sinking foundation in a house by putting up really expensive brand new wallpaper.
Oh, that's perfectly put.
Right, because if the wooden framing of the house is rotting, the best wallpaper in the world isn't going to hold the roof up. If a patient's pelvic floor muscles are profoundly weak, or if they have a physical pelvic organ prolapse, burning the surface tissue with a laser to create a little bit of collagen isn't going to fix that massive underlying structural failure.
That analogy perfectly illustrates the regulatory concern. A laser is simply the wrong tool for muscle weakness. And the clinical literature points to an even more complex diagnostic trap, which is the paradox of pain.
Okay, this is a wild medical nuance. Explain how pain or muscle spasms can actually mimic looseness.
It's vital for anyone considering these treatments to understand this. A patient can have a hypertonic pelvic floor, meaning their deep pelvic muscles are overly tight, constantly clenching, or in a state of spasm. That muscle tension causes pain, but it can actually coexist with and completely mask loose surface tissue. If you apply a heat-based laser to a patient who is already experiencing severe muscle spasms, the microtrauma could theoretically aggravate their pain and make their condition worse.
Wow, so you're treating the wrong thing and making the actual problem worse. And there's also the issue of nerve damage, right? Which happens frequently during difficult childbirths. If the pudendal nerve is severely stretched or injured, it can cause localized numbness.
Right. And how does the human brain interpret a sudden lack of sensory feedback in the vaginal canal?
As looseness.
Exactly. It frequently interprets numbness as a feeling of looseness or an open, gaping space. The patient feels loose because they literally cannot feel the tissue gripping.
Oh my gosh. So if a clinician doesn't perform a proper neurological and muscular assessment and just assumes the patient's complaint of looseness means the tissue needs tightening, they will end up applying an energy-based device to a nerve problem.
Which is useless.
Yeah, a laser will not fix a stretched nerve.
Not at all. And this is why the standard of care is so rigidly defined by regulatory bodies like NICE in the UK. Their guidance is incredibly clear and deliberately cautious. They strictly prioritize conservative care as the mandatory first step.
Right, you don't just jump straight to the...
Exactly. Before a patient ever sits in a chair for a laser or RS treatment, they must undergo a comprehensive assessment by a qualified specialist. Is the sensation of looseness caused by a prolapse? Is it a muscle issue? Is it the genitourinary syndrome of menopause?
And if the diagnosis reveals muscle weakness, the first line of defense isn't a laser, it's pelvic floor rehabilitation and dedicated physiotherapy.
Yes.
Or if the issue is menopausal tissue thinning, the first step might just be topical estrogen therapy.
Correct. The regulators currently treat these energy devices as adjunctive therapies, meaning they should be used as an add-on to conventional proven therapies. Or in some contexts, they are still considered experimental rather than a routine first step.
Makes total sense.
The goal of these strict guidelines is just to ensure that the cutting-edge device isn't just masking a symptom, but that the true underlying anatomical problem is being accurately identified and safely resolved.
So, what we've discovered today is this really fascinating tale of medical nuance. We started by exploring the incredible science of neocollagenesis, seeing how ablative CO2 lasers, ERYA heat, and RF waves can literally trick the body into manufacturing thicker, stronger tissue.
Really is amazing science.
And we saw how the engineers behind these devices created brilliant hardware solutions like swapping out adapters and limiting power output to ensure that sensitive external areas like the introitus are safely protected from the intense energy used deep in the canal.
Right.
We even looked at the hard biomechanical proof from VTI sensors showing that the tissue resistance genuinely doubles.
Because the technology itself is undeniably powerful. I mean, the ability to safely stimulate targeted tissue remodeling with exact precision is a massive leap forward for women's health.
But as the FDA and NICE warnings make abundantly clear, a laser is still just a tool. And if a patient's true problem is a torn pelvic muscle or a damaged pudendal nerve, the most advanced, highly customized laser in the world is ultimately useless.
Completely useless.
It's a story of incredible tools requiring equally incredible diagnostic precision.
Which is exactly why consulting a specialized medical professional rather than just booking a quick cosmetic appointment is so critical.
Absolutely. And that leads us to a final provocative thought for you to mull over after we wrap up today. We've spent this entire deep dive talking about how these energy-based devices remodel structural tissue. The collagen, the elastin, the cellular matrix. But what about the nervous system itself?
Oh, that is the next logical frontier for this kind of technology.
Think about it. If we know that these devices can purposefully create microinjuries that stimulate deep cellular repair and flood a specific area with healing factors, could the next generation of energy-based treatments be engineered and customized not just to tighten mucosal tissue, but to specifically target and regenerate damaged nerve endings?
Like, could clinicians eventually use a highly specific frequency of radio waves or a targeted laser depth to restore lost physical sensation after severe childbirth trauma?
Yes, that is a frontier of biohacking the human body that goes far, far beyond simply tightening lax tissue. It's bringing that absolute dial-level precision into the often muddy waters of pelvic health, ensuring that the complex neurological foundation of the body might finally get just as much high-tech attention as the surface wallpaper.
It's a fascinating area of ongoing medical research, and honestly one that holds the potential to change millions of lives in the future.
Definitely. Well, we hope this deep dive gave you a much clearer, scientifically grounded picture of the incredible mechanics and the necessary cautions behind this booming medical field. Keep asking questions, keep looking for the why behind the technology, and we'll catch you on the next deep dive.